Okay, in this short video, we are going to talk a little bit more about the neuromuscular junction. And let's just review the parts of a neuron, right? These are dendrites, these little branches coming off, those would be dendrites. We have the cell body, we have an axon. It's a myelinated axon. These are Schwann cells that are myelinating. And the action potential is moving all the way down the axon right to the axon terminal, where we have the synaptic end bulbs, where the axon terminal meets the muscle. That part of the muscle is called the motor end plate, but where the two meet, it's called the neuromuscular junction, the NMJ, neuromuscular junction. Now, off to the right, this is more of like a linear drawing to help us understand some of the parts, but this part right here is going to represent the synaptic end bulb. And you can see these little tiny dots in there. Those little tiny dots are the little vesicles that contain a neurotransmitter. That neurotransmitter, remember, is what we call acetylcholine, ACH. But something has to rush in here, and what has to rush in there to tell that neurotransmitter to release itself in the synaptic cleft is going to be calcium. So calcium rushes in. That neurotransmitter is going to move into that synaptic cleft. You can see the 1, 2, 3, it looks like 4 little dots there. Those 4 little dots would be the release of that acetylcholine. The release is done through that method called exocytosis. The acetylcholine is going to bind with receptors on the motor end plate. So this is the motor end plate of the muscle. Acetylcholine binds to those receptors. They open up, and what rushes in is sodium, Na. Sodium rushes in. When sodium rushes in, it creates excitation. It creates an action potential, depolarization. And it's going to go down this tubule, this invagination right here. This invagination, I'll put a T there. The T is for T-tubule. Right? If you think back, here is the T-tubule. And what binds or what connects to the T-tubule? That sarcoplasmic reticulum, this blue meshwork, the webbing. And what does that sarcoplasmic reticulum store? Calcium. So let's go back here. Now we have this T-tubule that butts up against this sarcoplasmic reticulum, which stores calcium. And calcium is released. So the action potential goes down the T-tubule right into the sarcoplasmic reticulum. The sarcoplasmic reticulum is going to release calcium here to this section called a sarcomere, which is made up of thick and thin muscle filaments, which are going to be all of these. I'll put a big X in there. So this sarcoplasmic reticulum is going to release calcium. You can see deep to it are these thick and thin lines, the blue and red lines. That's the sarcomere. It's made up of actin and myosin, those contractile protein filaments. And somehow calcium is going to make the muscle contract, which we know means to produce tension. Now, there are some more details here. There are some details that we have to go over as to how does calcium make this muscle contract. And that's what we're going to go over. Let's review here one more time. Let's erase this. So we have right here We have the end of the axon terminal where you have the synaptic end bulb. You have that neurotransmitter acetylcholine that's stored there, but we know that calcium is going to rush in. When calcium rushes in, it forces the release of acetylcholine into the synaptic cleft. So that gap right there is called a synaptic cleft. The acetylcholine is going to bind to those sodium channels, and then when the sodium channel opens, sodium rushes in, creating excitation. The excitation goes down the T-tubule. The T-tubule, you can see right there, butts up and touches the sarcoplasmic reticulum, which stores calcium, and it releases the calcium, where we have thin and thick filaments. The thick one is called myosin. The thin filaments are called actin. Somehow calcium is going to make the muscle contract, and the term contraction means to produce tension. When we come back in the next video, we will talk a little bit more about calcium's role in producing the actual contraction.